G'day guys, we've got a few matrix multiplication questions for us to go through today by viewer request. I'm going to explain what we need to look for before we even start our matrix multiplication, and then we're going to go through the matrix multiplication algorithm in three different matrix types. Okay, so let's start by having a look at if the matrix multiplication is actually possible and how we work that out. Okay, so with a matrix, we have what's called dimensionality. Now, what dimensionality means is how many columns and how many rows do we have, or more specifically, how many rows and how many columns do we have. So to work, that'll be usually described, we've got m by n matrices. So what this is we have how many rows, so we go down first. So how many rows, so this is this way, do we have, and how many columns do we have by this way. So we'll go through and we're going to list the dimensionalities of each of these matrix types, and I'm going to explain how we use this to figure out if the multiplication is possible. So to start with, what we have here is we have a 2 by 2 matrix. And we're multiplying that with a 2 by 1 matrix. Now, to figure out if the matrix multiplication is at all possible, what we have to do is the columns of the first matrix, and the order is important, so the columns of the first matrix, or the second number, have to match the rows of the second matrix. So the inside numbers of our dimensionality, if we're going to multiply them together, have to match. And what we also find is we find that the resultant matrix that we're going to get is going to be equal to the second two, the rows of the first matrix and the columns of the second. So that's our matrix that we expect is a 2 by 1 at the end. Okay. So let's go to the next one, have a look at the dimensionality. So this one here will be okay. We'll be able to multiply this no problems. The next one, we have a 4 by 2 matrix, and we're going to be multiplying that with a 2 by 3 matrix. So the inside numbers match, and we should expect at the end to get a 4 by 3 matrix. Now the last one, we have a two square matrices, so we have 2 by 2 being multiplied with a 2 by 2, and as you can imagine, we're going to have a 2 by 2 matrix is going to result when we multiply these two together. Okay, so let's go about doing the matrix multiplication, and we'll go through the algorithm that's required. So what we're going to have to do is the matrix multiplication works by, we take the first row of the first matrix, so in this case it's going to be 5 and 4, and we times it by the first column. Well, this is the first and only column in this matrix. So the way we do this is we're going to go 5 times -4. So 5 times -4, and then we're going to add that. So let's put this in a double set of brackets. There we are. And then we're going to add that to 4 times 3. So that's going to be add to 4 times 3. And then what we're going to do is we're going to get the second row of the matrix, this one here, and we're going to multiply it by the same column, the first column. And we go, because this is the second row, we're going to go down into the second row of our matrix. So this is going to be 2 times -4 plus -1 times 3. Cool. So let's work this out. We've got 5 times -4 is -20. Plus 4 times 3 is 12. And we have 2 times -4 is -8. Plus -1 times 3 is going to be plus -3 or just -3. And then we finally just compute the answers. So we have -20 plus 12 is -8. And -8 take another 3 is -11. And we've resulted in a 2 by 1 matrix at the end, which is what we're after. So we're happy with the first one. Cool. Now the second one's going to be a bit more long-winded, and as a result, I'm not going to do this step here because it'll take us all flipping day to write all those down. So let's change color though. So we're going to do the first row multiplied by the first column. So we're going to go this row times by this column. So this is going to equal -2 times 2 is -4. -6 times -2 is +12. So we have 12 take 4 is 8. Okay, great. Now, we're going to do the same row and then we move columns. So we're going to go to here now. So -2 times -2 is +4. -6 times 0 is 0. So the next one is just going to be, you guessed it, 4. And then we're going to do this row times by the third column. -2 times 2 is -4. -6 times -3 is 18. So 18 take 4 is 14. Great. Now, what we're going to do, just change color, and we're going to go to the next row. So first of all, we're going to go to the next row times this one. -4 times 2 is -8. 3 times -2 is -6. -8 minus another 6 is going to be -14. We then go the same row times by the next column. -4 times -2 is 8. 3 times 0 is 0. So it's just going to be 8. Then we go to the next column. -4 times 2 is -8. 3 times -3 is -9. So we have -8 minus another 9 is going to be -17. Cool. So we go on to the next row, multiplying it by the first column. 5 times 2 is 10. 0 times -2 is 0. So the first one's just going to be 10. Then we get to the next column. 5 times -2 is -10. 0 times 0 is 0. Then we go to the next column. 5 times 2 is 10. 0 times -3 is 0. Cool. And finally, we're going to go to the fourth row. The fourth row times the first column. We have 4 times 2 is 8. -6 times -2 is +12. 12 plus 8 is 20. We have 4 times negative 2 is negative 8. Negative 6 times 0 is 0. So we're just left with negative 8. Then we go to the third one. 4 times 2 is 8. Negative 6 times negative 3 is positive 18. So we have 8 plus another 18 is 26. Cool. So the reason I use different colours here is so you can see where each of these numbers came from. So we have the 2 and the negative 6. When we multiply it by each of the 3 columns, we get 8, 4, and 14. Negative 4 and 3. When we multiply it by the 3 columns, we get negative 14, 8, and 17. And we just can check on our dimensionality. The dimensionality of this is going to be 4 by 3, which is what we expected using our dimensionality check at the start, and so we're happy with that one as well. Okay, so finally, onto this one here, which is a bit of a curveball because it has some algebraic terms in it. But overall, shouldn't be too hard. We're just going to go through it nice and slowly. So the first things first, what we're going to do is we're going to get our first row. And we're going to times by our first column. Cool, so we're going to have negative 4 times negative 4x is going to be positive 16x. We're going to be going negative y times 2y is negative 2y squared. Great. Now we're going to get the first row and times by the second column. So we're going to have negative 4 times 0 is just 0. And negative y times negative 5 is going to be positive 5y. Cool. Now we're going to have the second row. We moved on to the second row. And we're going to times by the first column. So we have negative 2x times negative 4x is going to be positive 8x squared. We have negative 4 times 2y is going to be negative 8y. Moving on to the second column. We have negative 2x times 0 is just 0. And negative 4 times negative 5 is 20. And we can check that this is definitely a 2 by 2, 1, 2, 1, 2. So we're happy with that. Cool. You can see that the matrix multiplications, once we actually know the algorithm where we times the first row by all of the columns, then we move down to the second row, times by all the columns, move down to the third row, and on so forth and so forth, and timesing it by all the columns. The second question that we did is quite a good demonstrator of the algorithm because you can see that we go first row times all the columns, second row times all the columns, third row times all the columns, fourth row times all the columns. And you can see when we go the first row and timesing all the columns, we get the first row in our answer. The second row times all the columns, we get the second row in our answer. So you can see that this is quite a good demonstrator of how the algorithm works, where with the colors matching to the respective rows. So, and also you can see that even if we get some algebraic terms in our questions, the answer algorithm, or the algorithm that we use to derive the answer, doesn't change. All that I would suggest, guys, is that you spend time doing quite a few of these examples to ensure that you understand the algorithm and you can work through them quite quickly. Make sure your mental maths is good and always double check, because it's very easy to make an adding or subtracting mistake in these, or even a multiplying mistake. So I hope this video helped in determining how the algorithm works and whether we can actually even multiply the matrices in the first place. But yeah, as I said, keep practicing. If you have any questions, make sure you send them to me, and I love getting new questions. If you like the video, yeah, give it a thumbs up. Subscribe to my channel. I try and put out new videos all the time, and I'll see you guys again next time.